Today in this video, we will learn about analysis of algorithms. Let's begin, without wasting any time.
To find efficiency of an algorithm, we use two terms. First one is the time complexity. Second one is the space complexity.
The space complexity is the amount of memory required for your code to run and terminate. The space needed for your code to run and terminate is the sum of fixed and variable space. Now, what are fixed space? It includes the instructions, variables, and constant. For example, we give fixed size for some arrays, variables, and loop for termination. On the other hand, variable space includes dynamic allocation, recursion functions. The total space of any program is the space of program equals to the constant c plus the instances.
Let's take our example for space complexity. Here we are performing four operations. First one, declaration of A. Second one, declaration of B. Third one, declaration of C. Fourth one is the addition of A plus B. Now we multiply the operations with the number of declare variables, which is 4 operations multiplied by 3 declaration, A, B, C. We get 12 bytes as our space complexity for this code.
Now let's see what is time complexity. It's basically is the amount of time required for execution of your code, represented by big O, which is the frequency count of the code. Let's understand it by an example. Here in this function, there is no iteration, just taking an input and printing the input. So the time complexity of this example will be O1, because there is no loop or any iteration step in it. It gives the output in the constant time.
Here are few examples of the time complexity of different loops we use in our code. Let's now see the common rate of growth of algorithm. Consider n as size of input and k as some constant. These are all the common rates of growth used. Constant, as we have seen in previous example, it takes an input and gives an output. Linear is a simple for loop which runs till n number of times. Logarithmic skips k number in between and runs n number of time. Logarithmic linear is the same loop running n number of time and then skips k number in between and runs n number of times. Quadratic is basically loop inside a loop. Polynomial is quadratic, but the loop inside the loops are k number of times. Exponential is the worst time complexity for your algorithm, constant running in n loop.
Now let's see what is analysis of algorithms. The analysis of any algorithm is done in following 3 cases. Best case, the time taken on the best possible input data. Worst case, the time taken on the worst possible input configuration. Average case, typically the average time take on the average input data.
Let's take an example. In this function, if the input is 1 which is less than 5, then it will satisfy the first condition and print 1, else if the input is more than 5 it will go n times. It is the worst time complexity on n input.